Hello, participants. My name is Joshua Jitomobi. It's my pleasure to welcome every one of us to the online training on time series forecasting with the use of R. To start with, we shall be considering the concept and basic theory of time series forecasting. And when we are dealing with time series, we're actually dealing with time. And the time could be in years, in months, in days. And the basic aim is to derive hidden insights so as to be able to make informed decisions. So when we talk of time series, we are talking of variables that are measured sequentially, um, overall at a fixed time interval. The fixed interval is generally known as sampling interval, and the resulting data is called time series. The historical series are treated as realization of sequences of random variables, where we normally define a sequence of random variables as fixed sampling intervals. And generally, what is termed time series in short is discrete time stochastic process. And it shows the relationship between time and at least a quantitative variable. The theory could actually be studied without necessarily fitting any model, but the focus of this training will be more applied and directed towards model fitting and analysis of time series with the use of R software. But before moving to um, the analysis, let's quickly look at a few other things. What are the uses of time series? Time series can be used in a multitude of business applications for forecasting into the future and trying to get um, a clear view of the historical pattern. For instance, we may be interested in looking at the seasonal patterns in sales of a certain commodity. We may be interested in predicting expected number of customers. The interest may be okay. We have a new product, and what could be the effects? We may be interested in detecting some unusual events and estimating what the effect could be. In terms of real life examples, recently the climate change summit was held, and the argument for reducing greenhouse gas emission definitely rely on combination of various time series analysis coming from science, economics, or various disciplines. And whether we like it or not, we still have to make decisions that will affect our future in the area of climate change. And such decision definitely will rely on our basic understanding of time series analysis. Another real life example, current one, is this COVID 19. And we are definitely going to look at COVID 19 data. Uh, we want to really look at what is the effect of this COVID 19 uh, vis-a-vis the use of various stringent conditions. Then we need some knowledge of time series. Even if we want to look at what could be the effect COVID 19 on airline decisions, whether to expand, whether to contract, and so on and so forth, you need some understanding of this time series data. Then day to day, we look at demand and supply for various things: food, fiber, electricity, gas, water, automobiles. And we have our meteorological stations making weather forecast on daily basis. All these things calls for the understanding of some level of time series. Then in running our economics, we need some understanding of exchange rate movements, interest rate movements, even the entire economy measured by maybe rising or declining GDP and so on. All these things require some basic knowledge of time series analysis. So when we're talking of time series analysis, it has about four components. And when we're talking of these components, these are reasons or forces which affect the value of the observation. Um, The four categories include trend, seasonal variations, cyclic variations, random or irregular. And so when we're looking at the component, we look at the trend. The trend actually is defining the long-term movements. It could be rising, could be declining of a variable over some kind of long term. In terms of short term movement, we have the seasonal variation or cyclical variation. We are going to explain this later. Then we have the random or irregular movements. The trend shows the general tendency of the data to move up or decrease over a long period of time. The overall trend must be upward, downward, or stable. Take, for instance, we may be interested in population, agricultural production, manufactured items, number of births, number of deaths, number of industries, number of schools, colleges, and so on and so forth. Maybe interested in yield growth, uh, productivity, and so on and so forth. So, and all these have some tendency either to move up or decline or remain stable over some time. So if we're trying to look at it that way, then we are considering the trend. So if we plot time series values on a graph in accordance with time t, we can actually get the pattern of the data. So the clustering of the data definitely will show us the type of trend we are looking at. For instance, if the data cluster more or less around a straight line, then we talk of a linear trend. Otherwise, we say it is not linear, and we have various types of non-linear and so on. The seasonal variation, these are the rhythmic forces which operate in a regular and periodic manner over a span of less than a year. So they have the same or almost the same pattern during a period of 12 months. So the variation will be present in time series with data recorded hourly, daily, weekly, quarterly, or monthly. I'm emphasizing that because there is no basis of talking of seasonal variation when you are using annual data. So this variation come into play either because of some natural forces or some man-made forces. Take, for instance, the various season or climatic conditions that play important role in deciding um, our harvest. For instance, production of crops depends on seasons. The sales of some umbrella, raincoats, and several other winter clothes. It depends on the season. We have the sales of electric fans and AC also that usually go up during summer. And we have some man-made forces such as some festivals, custom habit fashions, and several occasions that usually dictate seasonal variation. Cyclic variations is almost similar to that of seasonal, but the basic difference is the time dimension. So when we talk of cyclic, the variation in the times the variation in the time series operates over a span of more than 1 year. So the oscillatory movement has a period of oscillation of more than 1 year. That's the difference. So the cyclic movement is sometimes called the business cycle. So that's why you can have time of prosperity, time of recession, time of depression, time of recovery, and so on and so forth. And definitely, cyclic variation also depend on various economic forces and the interaction among the macroeconomic variables. When we talk of periodic fluctuation, these are some components in time series which tend to repeat themselves over a certain period of time, and they act in a regular spasmodic manner. Random or irregular movement, on the other hand, these are purely random or irregular time series. The fluctuations are unforeseen, they are uncontrollable, sometimes unpredictable and erratic. Um, Example, we have earthquakes, wars, flood, famine, any other disaster. Mathematically speaking, Let's represent the variable by yt and the time dimension by t. So we say that our yt is the value of the variable under study and at time t. So if the population is a variable under study, for instance, at various time, then the time series is t1 to tn, or we say yt to ytn. And we can divide the model into two. We have the additive and the multiplicative generally, or let's say three, because we can have mixed model. Um, if it is additive, then the time series can be expressed as yt as addition of various components, trend, seasonal, cyclic, and random. And if it is multiplicative, then what we are saying is that the various components operate proportionately to each other, and we can have mixed model. I sent one ebook to us, so please let us please go over and read more about all these things. They are well explained. So what are the main features of time series? The main feature of many time series are trend and seasonal variation that can be modeled deterministically with mathematical functions of time. So another important feature is that observation close together in time tend to correlate. So our interest at times also will be the serial correlation. So much of the methodology in time series analysis is aimed at explaining the correlation using various models and descriptive works, statistics. So once we have fitted a very good model, then the work is almost half done. Then we can use the model to forecast future values or generate some simulation in order to guide our decision plans. So finally, a fitted statistical model provides a concise summary of the main characteristics of a time series, which can often be essential for decision makers, such as managers and politicians. We can divide the methods of analysis into two. We have the frequency domain models and time domain. Uh, Example of the frequency-based spectral analysis, cross-spectral analysis, wavelength analysis. We are not dealing with those ones here. So our focus will be the time domain ones. So talk of autocorrelation, cross-correlation. We have autoregressive models, autoregressive integrated moving average, and so on and so forth. So please, just as I said earlier, please let us ensure that we read the book so that we can have sufficient